Alright, look at this very carefully. Look at the patterns of all the different striations of rock. And look at this stuff here. You see how powdery that stuff is? How easily that could wear away? Now I want to show you something that's on Mars. And here it is right here. You see much of a difference? I don't see any difference at all. Whoops. If you took and eroded the rock that I just showed you, you would end up with this very, very fine red powder, because that's blood. And the rest is muscle fiber. And look at this. That's a pattern of muscles. These are not the pattern of, look at these, they're weaved in and out. This is the pattern of muscles, and I've shown this over and over and over. And there's no question what it is a pattern of muscles. And so what it is what it is. And on Mars, it's so dry that the blood erodes away. It just powders off and dries out and erodes away. And that's what they see all over Mars, is a red planet. It's covered with this stuff. Okay, here's what I'm going to ask you to look at. This layer here is a red layer. Now, this layer in Siccar Point they call the old red sandstone. For some reason they decided that just laid down there in old red sandstone. I say this is blood. Bodily fluids which separate out your tissues and tendons and so forth. Now, this is obviously all the fibers. You can see individual fibers, copious amounts of them, and there's just no question about that. Now, these are the bundles, and they snap off in a certain area, and that just happens as they transition down to the different types of collagens and keratins, which are in there, that end up turning into tendons. So this is the muscles, and the tendons would come in a different spot. Now, there's blood running between all of these. Everything in your body has to be serviced with blood, or it won't work. Now, this is a layer of old red sandstone, and then there's of course another one down here, which that's just the way life goes. You get a layer of this and a layer of that, and it's like a layer cake. And that's, I mean, this stuff here, this didn't show up here by sedimentary formation. It's just not the way it is. If you look at these carefully, you'll see that the patterns in there, there's no way they can be made. They flow in and out of each other in a fiber. So it's not possible for this to be sedimentary. Okay, you see my specimen here, and I'll look right up here. There's Siccar Point. It's identical. It's identical, same stuff. It has this, and then it has this eroding old red sandstone, they call it. Well, that is a layer of blood. And I will show this thing in exquisite detail, because it exactly is the emphasis point of a tendon, to where the tendon and the muscle come together. That's where I'm finding these things in the Giants. The Giants Causeway is the same thing. And I have a video on that's extremely obvious. There's no question whatsoever. And it can be tested with the chemistry. And I'm saying there's no question whatsoever. You come up with your own idea. But if you see what I'm saying, I think you'll have to take some consideration of it. Alright, this is the kind of exquisite fossilization we have in mud fossils. Now, there's one of these little flaps here, I guess in that it would be something similar to this. And what it does is it comes over the top, and there's like a little triangle investment, and there's a bunch of them. And what happens is this is the fascia, and that goes out, and it comes very, very thin as it goes out over the top of the muscle. And every single muscle fiber is coated with fascia, but it's very, very thin. But that's why all of this stuff becomes separated. Now, as this comes across, this actually ends up coming down like a tube. So think of it this way. This is like a sausage going out this direction. Now, let me back this up if I can. Anyway, this is like a sausage going out in this direction, and the tube comes over the top and twists it around like, and it's exactly what it does do. And it starts to change chemicals, and they always break as it starts to go into this tube. And this little tube comes down, and then in tendons, a ball will invest right into the bone. And that ball is mineral, and I can show you exactly how that's formed, and there is a chemistry behind it. And once they set up inside the bone, it creates these spiky minerals. And this is all understood. It's nothing I'm making up. Now, when I spoke about those spiky little mineral balls, they're going to be, they're plagioclases. And they're going to be around there somewhere, because they're always there when you find tendinenthesis points. There's plagioclases, which are these spiky, round, ball-looking things. As a matter of fact, I'll show you one right now. All right, this is a partially incinerated tendon assembly. And what happens with tendon assemblies, they have like a little strap that comes down, and then there's a ball at the end that's locked into the bone. This is the ball. That ball, and they have spikes. They're all spiky little plagioclase materials. And this is what happens with these. It's so fully understood. It's a biological process. When they embed in the bone, that's what holds them from pulling out. Now, out there comes a strap. Now this strap, as you can see, is consumed. It's all burnt up. And the strap is a different chemical material. It has like vascular stuff inside of it so that it can expand and pull and move and so forth. This is a mineralized component. So the two different materials. And the body the body is so incredible. There's 20 different types of keratin or more, 20 different types of collagens or more, and they all do separate things. Some of them protect from acids, some of them protect from bases, some of them are neutral. Your veins separate everything out. Your fascia is on every single fiber of your body has fascia around it, which separates it from every other single fiber of your body. Absolutely incredible. And they think that the fascia now, they may be thinking that it is something to do with the actually a fiber optic system that runs throughout your body, because these are tiny little fibers filled with fluids. The Germans are doing some research on this just recently, but I had to do a lot of research on fascia because it's the component that facilitates the fossilization in wet conditions. And here's the process. You get buried in a wet mud, immediately you will begin to get electroplated because the earth has electric currents in it. They're natural, they just happen in wet muds. It's been proven by by Alberta, Canada. It's totally proven. It's fully understood. There's a name for it. They're spontaneous potentials. Anyway, those electric currents create a plating on organic matter that gets buried, and that plating literally coats it so that it eventually becomes a stone inside. It lithifies inside, but the stuff that's inside is because it lithifies because of the ionic nature of organic matter, and because the electric currents in the water, it drives things into it. Now the ones that are in dry conditions, in the sands and all that, with the oxygen and scavenged bones, those are just scraps of metals, really. They're calcium and phosphorus and this and that, but there's nothing in there that anybody wants to eat. So that's why they end up being in the ground. And they find them in the dry conditions. They think that's the only place to look for bones, and they're just absolutely 100% wrong. The absolute best place is the wet places, and the wetter the better. And the finer the particular muds, the better, even better. And if you can get down to the molecular layer, you were going to get the unbelievable preservation that is literally like it was in, you getting ready to eat. You know, I wouldn't eat that. You know, it's going to be tough on the teeth. But this has all of your fascia. It has all of your fibers. It has the elastin fibers you can see in there. It's just amazing. The red muscle, the white muscle. And what will happen in the fossilization process is the red muscles will erode, and the tendinous material will stay. And the ones that are in the transition are where they fracture. And that's just the way it happens. And it happens on every single one of them that we have. All right, very quickly, this is by dev.biologist.org, and this is how tendons are built in the body. And their job is to anchor muscle masses and keep your body from falling apart. And the tendons anchor, and when they first develop, they set up in this manner. And then you see the stem. There's a stem, a little tube that comes out, and it's a strap, and it becomes flexible and pliable to some degree. And then mineralization starts to take over in the center. And then you see this here, you got this mineral, and then you got something else changes to here, and then you got to this, and then there's about 2 or 3 other chemical transitions until you turn into the muscle mass. And when they fully develop, you get this very, very highly spiky mineralized, and it says right here, mineralized, all spikes everywhere, and it is spiky, and that is inside the bone. So the bone is like right here in a cavitation, and then that holds it in there, and this thing pulls it, and it keeps your muscle from flopping around. And this right up above it is what is inside the mud fossils, and that right there is the circular pattern of a tendon investment, and those are the gnarly little balls that fit into the, in other words, that thing came down like this and invested in, and it's circular, and it has ridges, and they have balls that invest in. And there's an exact identical one of these on Mars that's completely eroded away, because everything inside between it is a different sort of tissue. This is the stuff that stays forever, and it's called plagioclases. And guess what? The moon has plenty of them, and so do the comets or whatever they are. I'm telling you, the universe is a living organism. Okay, all right, that is a tendon enthesis point, and those are the spiky plagioclases that you find in the round ball that invests into tissue. All right, this is from commonswikimedia.org, and those are the plagioclases that are on the moon. Those are the rover's pictures from the moon, and those are plagioclases, and those are the mineral implants in the bones. And then the strap that comes back from these is eroded away, and all of this dust here, that is all the sediment of the body. And believe it or not, cells turn into sand. Cells are sand. Feldspar is petrified cellular material. That's what feldspar is. And when feldspar erodes, it turns into sand. The earth is covered with sand, and that is the cells of creatures that have petrified and eroded. And I have recreated that process in the lab. And it's a process of electrification of tissues, and I will show that. Well, I have another video about that. Anyway, those flaky things, those are the keratins and keratin fibers that build up your skin, and they also build up the fibers of fascia. And fascia, as I said, hold on one second, I have to find my lung. All right, here it is. Fascia is the thing that protects the mud fossils. You see that? Same stuff. You see that little white flaky looking stuff in there? I don't know if you can see it or not, but I hope you can. That white flaky stuff. Now this is a petrified human lung, and it's been DNA tested. It is a petrified human lung. There's no question about it. And that is, and I've talked to specialists about this, that is, those flaky things are a type of fascia. I think they call it pleura or something like that in the lung. This is a deeper, a heavier amount of fascia. But you have fascia on every part of your body. Every single filament in your entire body is covered with fascia. Every tiny muscle fiber in your body is covered with fascia. And anyway, it's a whole new science in fascia too. But these rocks are so ancient that they could be some of the earliest rocks on the face of the earth. And I mean, this gold in here, there's all kinds of things. And that is exactly what you find in the places where the blood has turned, the metals in the blood have solidified, and your body concentrates things in certain areas, and these kind of metals and stuff like this, I don't know if you can see that well or not, but it's littered with all kinds of fancy little metalish looking things and shiny things, and that is the product of the body concentrating metals and certain elements where they need to be concentrated to do work. And in the tendinous areas specifically, and in the lungs, you get a lot of metals, and the metals end up creating seeds when they get purged out, and then you get crystals, and I have a whole nother thing about that. Geology is totally not correct as far as I can tell. And anyway, this is Siccar Point is not right. Siccar Point is a creature. That's not tectonic activity. That is a creature. All right, you saw that very, very old rock with the fire. Okay, now what I want you to think about is the stuff that's on Mars. And you can see this little striping stuff. Now, if you laid this over on its side, usually they're on their side, but there's sticking straight up on Mars as well. Now, this is the collision zone. See, it comes this way and it comes this way. Well, that's exactly one of these. This is a flap. It flaps over the top, and the muscle invests over it. And this is they grab onto the muscles this way to hold them, and that's what creates the tendon assembly. And I'll show you that on one of mine. As a matter of fact, I'll show you right now.